Oh, that's how I kind of understood that. So here he's trying to make class instance variables externally accessible, just like how instance variables are accessible for regular objects. So he's using the attribute reader method, and inside here he creates a class A and a class instance variable, which is A equal to 1. And then he defines attribute reader A by using, I imagine this is a singleton kind of pattern here. So what this does is that we can call the method A on the actual class A and have it return 1 to us. And I imagine one other thing he was trying to do here is that usually when you have a class and in the initialize method you do the attribute reader, no, in the initialize method you have some instance variables. Those methods you end up with will be accessible to all the instances of that given class where you've made that definition. So that is not what he wanted to end up with in this case. And that's why you see that he uses the singleton pattern to define this method A such that it can only be called on this class A as opposed to it being called on instances of A. And
Just
now we move on. Oh,
one minor
okay.
I guess like one minor correction that might be worth making is this isn't really the singleton pattern. It's just they do refer to the class of that immediate class of A does have the term singleton class in Ruby,
Yeah.
which isn't quite the same thing as the singleton pattern. Not that it's a big deal or whatever, but just clarify.
Oh, actually, it was just a lack of a better term. That's why I used the singleton pattern. But one thing I was sure of though is that it's a singleton, something related to singletons. Yeah.
Yeah,
So
I definitely would I think it is important. We shouldn't do it now, but I think it's important for people to get comfortable with that, what's happening with that class less than self, because unlike some of the arcane stuff we're seeing in this chapter, this is something that happens a lot in Ruby code. And I do think it is worth just wrapping your head around, like, so setting aside time later to make sense of this class less than self, if it's confusing.
oh, we can. I don't know if.
Yeah, I'd love.
Yeah.
Yeah. In the last book, this was referred to as the meta class instead of the singleton class. I've also heard it called the eigen class. Maybe meta class is less confusing, but it's officially called singleton class within the Ruby code. But yeah, like Nelson said, it is like a static class method in other programming languages, or at least that's the use case.
Yeah, but I do agree that it's more common to see it like how I guess Nelson said earlier, where it's like you have the function and it's like self dot whatever you're trying to get when you don't want to make an actual instance of the class. So, because I've never seen it like this, like
Oh, yeah, I see it. I would say I've seen both, but I actually feel like I see this a little more frequently. So it probably just depends on which code
yeah.
bases you're working in. Yeah,
Mm.
but I've seen both.
Okay. Yeah, but I think you guys are right that whoever's just like learning Ruby, they should really look at this, make sure you understand it, and then also the self function that we were talking about. I think it's somewhere in the book. I don't know where. Um, because both those things, I've seen them. I've seen the self function more often than this, but I feel like it is realistically used, especially with certain design patterns.
Yeah, you'll definitely see both. It's important. I think it is important to understand both. Yeah.
So I don't know whether Miles could help me rectify this. Is there like an alternative version of this syntax? Because I feel like I've seen syntax that achieves the same thing this code is trying to achieve, but without the class and then without the shovel.
Well, Andrea was just mentioning one, which is you do self dot.
I think it's
So
in
you
the
would do,
chat. Um,
yeah, you would do self dot a. You would do self dot like def self dot a and then return the instance. Well, let me look at the chat if that's what Nelson put.
You
Yeah,
can
so
also
Nelson's
you
giving
can
an
pull up
example.
DeepSeek and have DeepSeek show you because that's what I've been doing to like refresh my memory in this conversation. I'm just on my phone, so I can't like and DeepSeek's on the computer right now. But
Well, yeah, one thing that I'll point out here is that because we're using this attribute reader method, you
Yeah.
can't use self. Like you can't do self dot attribute reader colon a. That won't give the same behavior as this. You have to use class less than self to use attribute reader. One thing that's weird is that attribute reader, at least in the last book, it said it's more performant than defining your own method. But if you were going to do specifically this, you would have to abandon attribute reader and do def self dot a and then return at sign a inside of the body of the method. So you could do this without class less than self by using def, but then you cannot use attribute reader if you're going to do that, which is fine, I think. Potentially a tiny performance hit, but I think it's okay. Does that make sense, Newton?
Yeah, it makes sense. Maybe one other question I have is that in both these code pieces, we end up using self, and I have a question about that. Before we enter a method, I imagine self refers to the class itself. Is that the reason as to why the code works? The code ends up working because self is the actual class.
So it's confusing, and maybe Ruby needs better syntax or sugar for this concept. I think if I were to try to describe this, self, where you see self there, it is the class A. But the
Yeah.
class less than is saying take the singleton class of the expression on the right and open that as the current class that I'm operating within. So the thing on the right there is an expression. We're going to take that expression and get its singleton class and start working with that instead.
Yeah.
So it's kind of like we're doing self.singleton class dot define method. So this code right here, here's another way you could do this, Newton. You could do singleton class dot attribute reader colon a. That would be yet another way to do this. That might actually be less confusing to you. I wouldn't advise doing that in the code because no one really does it that way, but you could do singleton class dot attribute reader colon a.
Oh, okay.
So, and I'll type that in the chat. So an alternative would be, class A singleton class. You could do that instead.
So
Does
in
that
this
make sense?
case, singleton class is it a method? Like is it an inbuilt Ruby method or?
Yeah. Singleton class is a method on class. Actually, no, singleton class is a method on object. So you can get the singleton class, I think, for any object. I don't know if you can get it on like integers and stuff. I haven't tried that. But yeah, singleton class is defined on object. So you can get the singleton class for any object. So when Andrea was talking earlier about def self.a, you can do def any object dot a, and you're defining a method on that object singleton class, whether it's a string or a class or whatever the heck it might be. But I think that we should probably move on. But this is important to understand. I think if you are a Ruby programmer, this is a mental model that I think it is actually, I don't think it's as important to understand the constants lexical versus class ancestor scope. That I don't think that's quite as important of a mental model to like have memorized, but this mental model around singleton class, I do think if you're a serious Ruby programmer, you do need to understand that mental model well. So I do recommend setting aside time and
Yeah.
studying this until you actually do understand the mental model. But probably for the purposes of this book. So this book is assumed that, so something to point out, this book is not trying to teach you about singleton classes, it's assuming you already have that mental model. So probably we should move on, but it's something that Newton, you should make sense of. You should set aside time to make sure you understand this.
Yeah. Okay. So, oh, maybe one question, and it's not related to that. When you create a class, now let's say this class A, yeah. So you say class, and then you type the name of the class. I read somewhere, and it said that all classes are instances of the class. And when I was looking at this subsection, he also mentions it, but um, I don't know if anyone could shed more light on that because I wasn't familiar with a class named class.
So
If that makes sense.
yes, if you do a dot class, you will get the class, which is capital class. What the author is saying is you could put this instance, you could put this A attribute reader on the class, and then A would have access to it because that's its superclass. The
Yeah.
problem there is now all classes in the entire system have this method A, and that wasn't your intent. That's
Yeah.
why he's using by using the singleton class, he's scoping it to A and not all classes in the
Uh,
system.
okay.
Oh, sorry. Can I ask something, Miles?
Mhm.
Can you show how, if you wanted to scope this on their like class with what he has here without using this less than, how would he do that?
Using the less than. Well, you could
No,
just do
without.
so in the code example I gave in the chat. I just call the method singleton class, and it gives me a reference to the singleton class.
Yeah, of class A.
Yeah,
So, but
of class
you said,
A, because class A is self in that context.
okay, but you said that he did this. Or I think you said that he did this class less than self, this whole singleton thing, so that it won't be for all instances of class and only for.
Mhm.
So I wanted to know how he would have, you know, done that or made that mistake just from this bit of code here without referring to class from the start.
I guess I don't fully understand. Is it okay if I share my screen? Because I could type what Nelson is typing like in a terminal, so we could all see
Okay.
it. But Nelson's giving some examples.
Oh,
But if you guys would like, or something we could do, we could actually do this after the book club. If you want to just hop on a call or something, we could also do it separately. But
yeah, we could do
like
that after the
for
call.
think of it this way, like if instead of self less than class or singleton class dot attribute reader, if the author had done super class dot attribute reader :A, that would go on all instances of class in the entire system. So then if you did object.a, it would actually have that method because object is a class. So we don't want to put it on the super class. We want to put it on something between the current object, which is a class, and its super class, which is class. We need an object something in the hierarchy between the superclass and the current object, and that's what the singleton class is. You can think of it that way. Think of the singleton class as an ancestor between the current object and its superclass. Is that helpful? Like, is that a helpful mental model?
Yeah, that's helpful. Yeah, because I
So
was
it's
trying to.
almost like it's like the singleton class is the true superclass, but it's like semi-secret and unofficial.
Yeah, that makes sense to me. Okay.
Oh yeah, actually, I don't know. I can stop sharing and then he demonstrates it for you. But then another thing is that the thing Miles keeps on referencing about the secret class, it's something you can read about in Ruby under a microscope. The guy talks about it in a certain chapter, so you can
Oh,
see why it's actually referred to as a hidden class or a meta class, something along those lines. But let me stop sharing and then Miles will demonstrate and then we'll move on. Yeah,
okay.
yeah.
I, I guess that works too.
Oh my.
You know what's weird? Let's see. Okay.
Yeah.
Okay, I'm able to share my whole screen. Okay. So I'm not entirely sure what to type here, but we could just play with some stuff. So I could do class A. Actually, I think it's actually better if we do this with objects, because I think let's do ASDF. I can do single. I can do. I should be. Actually, I can't do ancestors, can I? Let me do this. A dot ancestors. Here we have a object. So you can see these ancestors here. The Sultan class is like actually, I guess it's not in this list, superclass. So if I do a dot superclass, I get object. If I do a dot singleton class, here I get a handle on this singleton class. So see how it looks different than A? So this singleton class, if I get its superclass, it would also be object. But I can put methods on that singleton class if I want to. And that singleton class sits between A and object. So if I put a method there and then call it on A, it will be found. So I can do a dot singleton class attribute accessor A, and then I can do a dot A, which is nil. But the point here, if I do object dot A, I get an error, right?
Yeah, because it's
But
only.
if I do a dot class though, I get this class. And if on here I do attribute accessor A, I'm not allowed to do that. Oh, I have a typo. If I do this, now when I call object.a, I get nil. The author is saying we don't want to pollute the entire class. We don't want to pollute all of the instances of class.
Of class,
We
yeah.
our intent was only to give access. We wanted an A attribute accessor method on that we could call from the A class without polluting all classes in the system.
Oh, nice. Okay.
And what Andrea was getting at was we can do this. We have this here. We can do def s dot, WTF.
And now it's that S.
Yeah, now I can do s dot WTF. But if I do like ASDF.WTF, I'm getting an error because that's not the same object. I put it on a singleton class, not its class. So only the object with this object ID has that singleton class.
So I guess now I feel like I can ask my question a little better. If you scroll up a little bit to where you say accidentally define that for all instances of class. So I was gonna what I was trying to ask was how from that line of code, like how would the author have accidentally done that in say that block of there a way that he could have done that?
I don't think that was the author. I don't think the author was trying to suggest that you could accidentally do it. Like
Okay.
one way
It's
I
just
guess
saying
you
that.
could, one way, yeah,
Okay.
one way I guess you could do it is if you did class a dot superclass, but no one would do this.
That would be so
Uh,
intentional. So,
that would be one way. The other way would be this dot attribute accessor, you know, Z. If I do this, now object.z, this method exists on all classes. Because my intention was to do what Nelson was referring to earlier as the static method in other programming languages. What I've done here is I've actually made a semi-global, it's not truly global because like S won't have the Z method. Oh, it does have it. Wait a minute, I'm kind of confused by that. Why does S have Z?
I think doesn't object.
Oh, you know why? It's because I actually don't know why that happened. So anyway, that's a whole other question. I actually didn't expect S to pick up Z because S is not a class. If we look at, or S dot is a class, there I am out of habit using the colon. I get false. So I didn't expect a dot superclass. Oh, that's why, because it's object. It's object. I'm sorry. I did
Oh,
superclass instead of class. Yeah, it totally makes sense.
instead of class. Oh, that makes
Um,
sense.
so I guess to answer your question, the only way would be to do this reader or self a dot class,
Okay.
something like that. But no one's going to accidentally do that, and I don't think the author is suggesting. I didn't interpret the author as suggesting that someone might accidentally do it. I think he was just mentioning that it's
Okay.
one
I think that's why.
option. One,
Hmm.
like
Okay. Okay.
if you wanted to
Makes.
put a method, if you wanted to put a method on a, so like you have an object, right, and you want it to have access to a method, you could put the typical thing you do with an instance of an object is you put that method on its class. I think the author is saying you
Yeah.
can't do that if the object itself is a class, because if you do that, if the object itself is a class, you're actually polluting all classes in the system. I
Oh,
guess
that
that's
makes sense. Because
probably
I
the
looked at
author's
the code
point.
and I was
Yeah.
like, huh, I didn't know that I could, accidentally do this, and so
Yeah, like
makes
I can
sense.
do s dot
All right. Thanks for clearing
class,
that up. Yeah.
and yeah, if I do s dot class, I get string, and then I could do, this is what would be normal, right? I want to put a method that's available to S. I would do, something like this. But now I've put that method on all
Yeah.
strings, which is usually that's usually what I want. But it's almost never what you want if
Yeah.
the object in question is a class. Yeah.
Makes sense. So
Anyway,
you instead do it on the singleton class of that class instead of doing. Okay.
yeah.
Yeah, makes sense.
The interesting thing is, look at this. If I do s.singleton class, oh, I do get what is S? Oh, I'm able to call singleton class on S. That's interesting. So you can see that I can do s.singleton class. I can do def s.singleton class dot whatever I want, or I could use I have like some kind of a problem there.
So if you do it on the singleton class of S, so that means that no other string will have that. It will just be
Correct.
for that
Yeah,
particular
like if I do
string object.
this,
That
like if I do this, I'm see how I'm getting different object IDs.
yeah,
These are
that makes sense. Yeah.
these strings don't have and it probably would be more clear if they had different characters, but these strings all have the same class. So if I do this class.object ID, it's always going to be the same, right? So if I put a method on that class, which is basically, like, you can kind of think of method or classes as like method dictionaries that its instances can use. If I put something in its class's method dictionary, then all instances of that class have access to it. But if that's not what I want, if I want more of a static method experience that Nelson was referring to earlier, Ruby's way of doing that is this. Put it put it in this class instead, and then this method dictionary is only owned by that object. It's not owned by all instances of its superclass.
Yeah,
Or of its,
makes
I should
sense.
say of its class, not, I'm using superclass incorrectly there. It's not shared. All instances of a class share the same class, but they all have their own singleton class.
Yeah, they all have their own singleton class. Yeah, but it makes a lot of sense now. I think that's where it started from. Just me misinterpreting the author's statement, and I was thinking there was this I don't know, fancy way of doing that from just that block of code. But I ended up learning some
Yeah,
pretty cool things in the way as well.
I'm kind of annoyed. I was hoping that ancestors would contain the singleton class, but it doesn't, and that, I think that would make it a little more clear. I don't know if it takes arguments or whatever, but we probably should move on. Yeah, we probably should move on though.
Yeah, I think we probably.
Yeah. So I'll stop
All right,
sharing.
thank you so much, Miles.
Sure, sure.
So I think we'll proceed now with the last section of the constants part. So here we are looking at just some naming considerations with constants. We've been doing this for we did this for the local variable section and then for the instance variable section. So we're doing it for the constant section as well. So for classes and modules, you should use a camel case, but camel case format of naming the class or the module. And then for other objects, use all caps snake case. I haven't seen this in maybe the projects I've worked on, but all caps snake case. Oh yeah, it makes sense. And then maybe for class names, you can do something like argument error or basic object. And as you can see, both basic object and argument error, they are examples of the camel case way of naming classes and modules. You start with an uppercase letter, you write out the rest of the word in lowercase, and then for the next word, you start with the uppercase, and then the rest of the word is in lowercase. So he talks about ASCII names. It's best that you keep the names to be ASCII names as opposed to using non-ASCII characters like emojis in the code. And then he says the names of the classes and modules should be long and descriptive. As you can see with argument, error, and basic objects, they're kind of descriptive and they show you what each of those classes is basically responsible for, or the purpose of those respective classes. And then he talks about a case whereby if you're working on a library and that library has a convention, for example, the constants of the SQL library are named in DB. In this case, the constant DB, you can see that it's short and probably not that descriptive, and it deviates from the rule he has told you that constant names should be a bit long and descriptive. But because of the fact that you're working on this library and this is a convention in the library, then you're allowed to break the rule he provided previously, and you adhere to the rule of that specific library. So in this case, your constant will have to be named DB as opposed to you renaming it to database or something along those lines. So replacing class variables. He starts out the chapter by telling you why it's not a good idea to use class variables, and after that he looks at the ways in which how you can replace class variables with either constants or class instance variables, and so on and so forth. So when it comes to class variables differ from class instance variables in the case that you can see he uses two at symbols when defining class variables. So inside the class A, we have a class variable A, which is assigned to the integer 1. And then here he opens up, he creates a singleton. Miles, could you remind me of the word you used? Because oh, eigen
Um,
class.
it, your audio sounds kind of garbled. I don't know if I don't know if it's just me, like my headphones or something, but does he sound kind of garbled to others? Okay. So yeah, sorry, oh yeah, now it sounds great.
I don't know. Oh, so what I was saying, you told me singleton pattern is a different thing. So as looking for the appropriate word to use for what he does here, because he uses the same syntax of class
Yeah.
less
So I
than
would,
self, and he's going to access the class variable.
yeah, the terminology I would use there is that he's accessing the class variable from the singleton class of A.
Oh,
So
okay.
on that very top line or that second line, he's assigning to the class variable uh, from A, like A self is A. On that next line, we are changing self to be the singleton class of A. And now from the singleton class of A, we are accessing the class variable A. I guess
Yeah.
I don't know if that's the best terminology. I'm sharing the terminology I would use to try to communicate.
Okay. So yeah, inside the class A, we proceed to define another method named B, and then we still access that class variable defined above inside B. So following that, we create a new subclass of A, which is B, uppercase, and inside this class, we access the class variable that was defined in A. So now on to what I would call some experiments. So here, he says a.new and then .b. And the b being called here is the method defined inside the class A. And of course, it's going to return, no. A, it's the class A. He calls the new method on the class A. So that's an instance of A. And then he calls the method B. But then this method is returning 2 because the class variable in B was reassigned in this code. Oh, yeah, I get it. So you have class B, and inside this class B, you reassign the class variable that was initially defined in A as equaling to 1. You reassign it to be equaling to 2. Now, when you come down here, you try to call the method B lowercase, which is defined inside the class A, and you're trying to access the value of that class variable, you can see that it's returning 2 instead of 1, which was the value of the class variable A initially. And what this shows us is that when you have a class variable inside a superclass and you proceed to reassign that variable to something else inside a subclass, you will see that both the value in the subclass and the value in the superclass are overwritten such that the new value you've reassigned is what will be the value of the class variable. And in cases where you're working with data, you can see that this overwriting of the variable would be potentially detrimental to the project you're working on. And the rest of the examples kind of along those lines of you have a reassignment that happens and you end up losing the initial value you started with. So now we proceed to replacing class variables with one of the Ruby variables, in this case, constant. So if you have a class variable, it's best to replace it with maybe a constant. And here we have a class A with a constant C equaling to 1. And then we create a subclass of A, which is B. And as we can see, when we try to access the value of the constant C inside the subclass, we are getting 1, as opposed to the value of, like what we saw in the class, in the example with class variables, the overwriting doesn't happen when we use a constant. So that is one of the advantages you see there. And then even when you try to reassign, initially C was equal to 1, but then we make C equal to 2. When we try to access the value of C inside B, which is the subclass of A, we'll see that C will equal to 2 because we've just performed the reassignment. And then when we try to access the value of C inside the class A, remember C was initially equal to 1 inside the class A, we'll see that we maintain the value of C as 1. So the overwriting doesn't happen when you use the constant. That's the key takeaway here. And let me see what he was trying to do here. Yeah.
Yeah,
So
that's agreed.
what he follows through next, remember when you try to when you try to reassign a constant, Ruby will always throw a warning for you. So in this case, what he's trying to do, I think he's trying to perform the reassignment such that it doesn't throw an error. Oh yeah, I think that's what he's trying to do with this code that ends up using a constant set. And then proceeding with that, he says because a constant can refer to a mutable object, it's possible to allow reassignment behavior without actually reassigning the constant itself, though I don't understand how that would be your aim. You're trying to reassign, but then you don't end up reassigning.
I think it's
Well, it's
because you're
what
not
it
changing
was.
the value of the
Yeah.
constant. You're only changing the properties of the data structure that the constant points to. So it always points to that same array. You can't reassign that. But now you're accessing that array and changing that array, like the value in that array. So it's like a way to work around that in a sense. It's kind of like
Yeah.
I think he has done this with a hash somewhere earlier in this chapter, or I think when he talked about the was it freezing the class and having like a cache instance variable that's a hash so that you can always access the hash, and something it's kind of the same thing in a sense. I don't know if I explained
Yeah,
that
I think so.
properly.
Yes, there's two things. There's the one Nelson just mentioned where it's surprising that these objects aren't frozen or even like deep frozen or whatever. Meaning, as long as you don't change the object ID of what C refers to, like your C still points to the exact same place in memory. Um, like it points to that array. So it points to the same place in that memory. What you're changing is the contents of that memory, which is what Nelson was just mentioning is surprising.
Oh,
So it's not constant for two reasons. It's not constant because you can change what place in memory it points to. You'll get a warning, which is actually annoying enough to stop me from doing it. But you can change the place in memory that it refers to and get a warning, or you can change the contents of that memory location and not to get a warning at all. And that's what the book is talking about. And then that latter part, I think, is what Nelson was just referring to as surprising, because it's not frozen. If you freeze it, RuboCop actually has a rule that when you assign something to a constant, you have to call dot freeze on it, and it's so that if you were to run the code that we see right there where it's doing plus equals, you would actually get an error. I forget the name of the error. It's something about trying to mutate a frozen object. Might be called frozen object error or something like that. But you'll get an error if you free. So on that line where he does C equals an array with just 0, if he added a dot freeze to the end of that, he would have gotten an error when calling increment.
Yeah, because what you're freezing is not the it's not the constant itself, but what the constant points to, which is that array, and then you can't do this plus equals since the array is now frozen. Sorry, I wanted to ask something. I think you can just ask now. Um, so constants. Nelson mentioned earlier that it was kind of surprising that um, in Ruby, constants are not actually constants. They just give you a warning. And so I wanted to ask if that's a good thing, because I know that in JavaScript, for example, it does this type coercion that can be somewhat annoying sometimes, where it just feels like a string, you probably wanted to do some you know integer operation on a string, and it would just like change it into an integer for you, and Ruby doesn't do that. It would just say that that method is not defined or something like that. So we say that that's a plus for Ruby because it's not doing what we don't want it to do. So I wanted to ask, is the way constants is defined or is designed in Ruby, is that a good thing? Would you have preferred it to be or you can't reassign a constant or something like that?
I would
Yeah.
agree. Yeah, I think it should be an error as well.
I think it's kind of strange then that like Ruby will be designed this way. It seems contradictory to me in a sense that they don't allow what automatic type coercion the way that JavaScript does, but then they let you change the constant. It seems a
Well,
bit
they
inconsistent.
do. No, I think so. I think the different Ruby does have some automatic type conversion. I think the difference is that JavaScript's automatic type conversion is just completely bonkers. So I think JavaScript's type conversion is just broken, but completely independently of any of this other stuff. Um, but like if you add like a float and an integer in Ruby, you'll get conversions and stuff. It's all happened. I think it's like happens like in the method levels. It's all message passing or whatever, but or magic that gives the impression of message passing. But yeah, I guess I personally view those as independent things. I
Okay.
feel like getting the warning if you reassign a constant in Ruby and get a warning is just like a bad decision in my opinion. And I don't know if they have to keep it around for backwards compatibility or some other technicality deep within Ruby's internals or something like that. I don't know, but that just seems like a bad design choice. Likewise, the conversion or the coercion in JavaScript also just seems like a bad decision. And I think the JavaScript conversion was put together under unrealistic time constraints too. Like, I think the way those JavaScript rules were thrown together, um, like if they had like a few more weeks to work on it, they would have made very different decisions, I think. So yeah, I think we're talking about multiple independent bad design choices. And I think these just happen because we're dealing with people like humans. Like you design
Yeah.
something, you think you're designing it correctly, and then once you see it being applied in practical use, that's like really when you discover if the design was good or not. And I don't think you can't perfectly pull that off. I don't think. So
Makes sense.
that's my opinion, at least.
I think the way Ruby does the say integer to float coercion, maybe you want to get like a float and you do an integer times a float. I think that one to me seems like you said, it's not bad like JavaScript. It seems more intentional and like smart because they're numbers at the end of the day. And so it's like if you want to get a float result, then you can. I don't know. I just okay. I feel you.
Yeah,
So
I, I think the same logic was happening when they made the JavaScript conversion rules. They just made the wrong choices. So I'm assuming they were like, I'm comparing this with this. What's the most intuitive thing to do here? They made a decision, and then it turned out to be counterintuitive. Um, so I think it's one of those things where they had decisions to make, and in JavaScript they just made a handful of bad decisions enough to where like and this a weird thing about JavaScript is it changes like every couple years, like what is a best practice or isn't. But in JavaScript, like there was a period of time where if you were writing JavaScript, you would never use the equals equals operator ever under any circumstances, because it was just like your linter would ban it because it was safer to use the triple equals, just because the triple equals gave more intuitive results. So if you're reading the code and you use triple equals versus double equals, you are more likely to correctly understand the code if it used triple equals. And that really, I think it really just comes down to they had decisions to make. They made the wrong decisions in a few cases. And then the end result is you really don't like the type coercion in JavaScript, and neither do I. And then likewise, I guess it must have been Matt's. Matt's had to decide what to do when you reassign a constant, and he decided to print out a warning. He must have had some reason behind that choice, but then in retrospect, all of us are looking back on it and saying that was the wrong choice. And I would assume that Matt's would agree with us, but maybe he wouldn't. I actually don't know. But he might agree with us. He might be like, I made the best decision I could with what was in my head at the time, and it turned out to be the wrong decision. And now I can't. And now if I fix it, I'm going to break a bunch of existing Ruby code. Like might be the situation.
yeah, it makes sense to me. All right, cool.
Yeah. So all this time, what we are trying to do is we are trying to replace class variables with other types of variables because of the disadvantages of class variables that we've seen. So the key takeaway from this section is that if you have a value that doesn't need to be modified, then using a constant is a good idea. But then if you have a value that probably ends up being reassigned to something else, it's a bad idea to use a constant. And in that case, you should use another approach, which we are going to look at. And that is class instance variables via the superclass lookup approach. So here we have a class A, and inside that class, we define a class instance variable C equal to 1. And then we create a subclass of A, which is B. And then following that, we write a piece of code which is going to retrieve the value C for the subclass B. And it's going to do this in such a way that if we have the class instance variable C defined inside the subclass B, it will return that value to us, which is the purpose of if defined C return C. If we don't have that value defined inside the subclass B, then we are going to look into the superclass of B, which is A, get the values, the class instance variable C defined there, and then return it to the user. So looking at this code, we see that class is equal to self. In this case, self will be equal to the class B. So we get the superclass of self or the superclass of B. We assign it to class. and then we say class dot instance variable defined C. So we are checking for the instance variable C defined inside the superclass of B, which is A. And then we do instance variable get C, retrieving that variable C, and then we return it. So in a case whereby you have another superclass of A, this piece of code will continue um, iterating and iterating until it either finds the instance variable defined in one of the superclasses, or it will return an error to you. So that is why it's called the superclass lookup approach. Because if you don't find the class instance variable defined inside the subclass, you go on looking inside each of the superclasses until you find it, or you return an error to the user. Then another approach that you can use is the recursive approach, which you can see here. Though this code was a bit confusing to me, it's like as if it uses a ternary if, something called a ternary if statement operator, and then yeah, it's confusing to me. I don't see where the recursion happens.
It happens on the superclass dot C, if I'm not mistaken. So if it's not defined
Yeah.
and it calls superclass dot C, then it will just be calling this same method, this a dot C again, and it keep doing that until it finds. It keep doing that, calling C on a superclass. So if it's not an A, if it's B that's superclass, it will call that again and again, this same method. I think that's like the recursive side of it to me, or that's how I
I wonder
understood
if
it.
yeah, I wonder if recursive is not the best word to use here. I'm gonna actually take a note of that because I didn't even notice that. Um, but yeah, maybe recursive is kind of confusing there. I had a different assumption. I actually assumed that the superclass had its own method called C. I didn't interpret this as being truly recursive in the sense that the same method was being called. But maybe what's happened, maybe the idea here is that, oh, it is. Yeah, I see. So B inherits from A, and that's what's happening. I see. So when we call up above, like a line above, I see. Yeah, I think Samuel was correct. Um, B dot C is actually, it looks up a method C in B's singleton class, doesn't find it, and then Ruby now must have logic that will actually go look in the singleton class for A, and it finds this method and calls it on with B as, you know, it calls it for B. So yeah, that's the recursion. It calls it once with B as self, and then that superclass.c results in this method being called again with A as self. That's what it is. That's definitely what it is. Yeah. So I don't actually need to take a note or whatever. I just actually misunderstood what was happening here.
Is
So
that
in
correct,
this
Nelson?
in this case, this is kind of like a class method. Like C is a class method on the class A, as opposed to it being like
Correct.
Yeah.
And then it's using instead of the less than self syntax, it's using the DEF syntax. But as we were talking
yeah.
about earlier, it's the same exact. It has the
Oh.
same site. It has the same exact side effect. So we're putting a C method on A's singleton class. I'm pretty sure in older versions of Ruby, this snippet of code actually would not work. I think you would get a no method error when trying to call C on B. But I think at some point, and I might be wrong about that, I think maybe in Ruby 2 or 1.9 or something, um, uh, the inheritance, I don't think the inheritance used to look through the singleton classes of the classes to find a method. I think that changed at some point. I'm like, but I'm only like 80% sure of that, so maybe we should just move on. But I think that played a role in confusing me.
I
Uh,
see. And
me
when I
what
read,
was mm,
okay, sorry. When I read this, I wasn't even thinking about this singleton class. I just I just saw sort of read it as being defined
Yeah,
in A, and so it's like,
that's the right.
oh, okay,
Yeah, I think
everything
that's
else
the right
has.
mental model. I think that's the confusing thing here. I think that's totally the right way to think about it. That's the correct mental model. Singleton class is the mechanism by which Ruby uses to implement that feature. So it's like when you're normally writing Ruby
Mhm.
class, I think that's when you're normally writing Ruby code, I do think that's the proper way to think about it. But if you actually want to know what's happening when you're executing these little tidbits of code, then you do need the singleton class mental model. But yeah, I also think of it the same way. I think of it as a quote unquote class method or whatever.
Yeah.
It just so
Okay.
happens that
Cool.
Ruby's approach to implementing that is the singleton class.
Mhm. Cool.
Oh, I actually hadn't noticed that this was a singleton method. As I thought it was like a regular method. I hadn't seen the a.c, but now it makes sense. Yeah.
Yeah.
So one advantage of what we've seen, the super lookup approach, is that, of course, in case you change something in the subclass, it doesn't change in the superclass. So that makes this approach better than the class variable approach. But then another advantage is that it uses minimal memory. But then a disadvantage is that it takes a lot of time, especially when you're doing that whole that whole iterative approach, or the iterative approach of looking through each of these super classes and calling those methods. So the time taken for such an operation to get done will be very long, especially if you have a lot of nesting in your code base. So there he talks about considering a trade-off based on what's important to you. If saving on memory is important, then the superclass approach is better. But then if you don't care about the memory bit, but you care more about the time that that is taken for the lookup to get done, then it's better to use the copy to subclass approach. So for the copy to subclass approach, we have a class A. We define a class instance method C equal to 1, and then we we define a method called inherited on self that is basically going to copy this class instance variable into the subclass every time we create a new subclass of A. In that case, when we try to access the class variable C from any of the subclasses, we'll be able to get it because it is copied by the inherited method at the time when the subclass is created by Ruby. So I think instance variable set, we've seen what it does before, and that is what this inherited method ends up using. And he talks about this method being less time intensive, in that it basically takes a shorter time for this code to run, as opposed to the iterative and recursive approaches we saw earlier. And that finally ends the subsection. So
I did take a note. I took a note that I think is kind of important on the section. What I like to do personally is I generally like to whatever approach I go with here, I like to encapsulate it in a method. So um, so the approach that he mentioned earlier, where he was doing something like C.superclass, but he wasn't encapsulating it in a well, I guess he was encapsulating in a method on the singleton class. I guess I just took a note that by and large, I try to access these instance variables through some kind of a method, and that helps me not get so confused. It's not as performant, but I find myself rarely, I've never been in a situation where the performance of this kind of thing is what was actually really slowing my program down. So whatever approach I tend to come up with here, I do kind of try to encapsulate it in a method as opposed to accessing all this stuff like raw in the class, which he does in a few places here, or like wiring it up in inherited and so on and so forth. So like this example here with inherited, I would never personally do something like this because I would want that C instance variable being accessed through a method with a meaningful name on the superclass and the base class or whatever. I guess I'm not expressing myself well here. I just felt like that's kind of something that I tend to do that the author didn't really address, if that makes sense. So
Okay.
so I would I wouldn't do this. I wouldn't wire up C in the inherited hook. So this inherited hook is a hook. I just wouldn't do it. I would have a method. I would have a method on the singleton class called C. I would basically not do this approach. I would do the previous approach personally.
Cool.
If that
Is it-
makes
is that-
sense. Like I guess I haven't personally ran into a situation where I would do this approach.
Okay. So I
I
want
do
to
think
ask,
it's
is that
important to understand how this works, though.
sorry?
I might
All right, cool.
I might also be lying. I might actually do this occasionally, but I don't know why I would do it. I would definitely generally prefer the other approach.
So I wanted to ask
I guess
Miles. Sorry, am I coming through?
Yeah.
My voice? Okay,
Yeah.
so I wanted to ask, why do you try to avoid accessing this directly? Is that because of maybe data hiding, maybe encapsulation or something, and so you only access it from one means instead of like everything having access to that variable? Is that your reasoning?
Yeah, there's actually two reasons, and it would be a case-by-case basis. Generally, in the code we're looking at here, I rarely would want it frozen in time at the point of creation of the class. Like, so in other words, if I don't explicitly set the variable on the subclass and then I do set it on the base class, I would expect to start getting the value set on the base class, which the previous code did. And this code doesn't. Now that's a case by case thing. You might have a use case where you absolutely do want to freeze it in time. I guess it is. It's kind of just here's like another point. I generally do not access instance variables directly at all. I almost always access them through attribute accessors, even within the class. One reason for that is if I put a typo in a method, I'll get an error. But if I put a typo in an instance variable name, I'll actually get nil. So that's one reason. But yeah, it is like a data hiding thing, but it's like hard for me to put into words at the moment. So I might have to kind of think through how I want to. I have like a good intuition around it, but I don't know how to put my intuition into words. But there's something that's like, I'm going to get confused by the code if I'm like doing an inheritance thing and there's instance variables involved and they're like, instance variables value is different at different points in the hierarchy. Like that's kind of like, that's something that I would rather just have a method that communicates what that data represents, and that the implementation, whether it's an instance variable or not, is out of sight, personally. So I don't know if that answers the question.
Okay,
but
cool.
Just like in general, I rarely access instance variables directly. I pretty much only do it when I'm like memoizing stuff. And my linter gives me an error if the instance variable I'm memoizing with doesn't match the method name, but that doesn't even really matter anyway, because I'm not accessing that instance variable anywhere else in the code usually. So yeah, I pretty much never use instance variables directly. Maybe I should. It's just I usually, even inside the class itself, I still call. So I guess here's the thing. If I have a public interface way of accessing the data, I use that even when I could use the private interface, just as a general rule.
Yeah. I feel you. It just feels wrong to you. It's like you're reaching into it and using it directly. instead of
I'm kind of like
through an
I'm
interface.
spreading. Yeah, like so basically I could switch between a constant and an instance variable. And if it's encapsulated in a method, I don't have to change, like I will not break any code. I haven't broken the contract with with any code. But if I switch between an instance variable and a
Mm.
constant and that's the contract, I've now broken all calling code that depended on the previous contract. So I guess it is kind of like a data hiding thing. If I use a method, I'm setting up an abstract contract um, where I'm encapsulating the implementation behind an interface. But if I'm just using the constants and instance variables directly, it feels like I'm using the implementation details as the contract. And it makes me,
Mm.
it doesn't jive with my intuition, I guess.
Yeah, I feel you. I would liken it to maybe r- inside a test. You're inside a test and you're reaching into a a class to get an instance variable that wasn't exposed by a public method, and so you're doing something like instance variable get, or you're calling a
Mhm.
private method from outside a class using .send or something like that. In which case, you probably want to redesign that class to expose what you want to expose or something. I feel like that's what you're trying to say. That it just feels wrong. It feels improper and unsafe and stuff.
Yeah, I guess you could say it's a smell. I'm assuming you guys are familiar with that term, like
Yeah,
where
it's called smell. Yeah.
you feel like you're seeing something in the code that you've formed a correlation with bad design. It doesn't necessarily mean it's bad design. It's just you've learned to correlate it with your intuition has learned to correlate it with bad design, and so you avoid it even though you're not sure if you have to avoid it or not. It's just like you see the smell and you avoid it just in case, but you could be wrong.
Makes
So
sense. Yeah, that's a
I would say
smell.
using instance variables as a interface between units of code, even if it's like inheritance, um, feels like a bit of a smell to me. Just like I would agree that calling send or instance variable get in a test is a smell. It doesn't necessarily mean it's the wrong thing to do, but it correlates with being the wrong thing to do.
Yeah, cool, cool. Yeah, it makes
Yeah,
sense
that
to me.
makes sense. Yeah, yeah.
So, what did you call that code smell again? Feature. Oh, Yeah, maybe even more than this one. 'Cause this one is saying that it does it. Yeah, it does it to an extent, and we're looking at something that does it at all and stuff. Yeah, because there's no public interface change. That makes sense. So it's definitely a code smell in that way.
Yeah, which doesn't mean you shouldn't do it. You might have a reason for doing it. It's just like if you don't,
Just suspiciously.
if you don't have a reason, then and you have an alternative, then you've kind of just learned, you've formed an intuition to just go with the alternative just in case, you know.
Yeah, for
Like
real.
maybe it won't bite me if I couple the superclass and subclass through their instance variables, but I could also just abstract it behind a method and uh, not have to worry about it, kind of a thing. Now, if this is like part of a pattern you're specifically using to pull off something very specific, then it would like not actually be a smell anymore. But then you actually know why you're doing it, you know. And
Yes.
it could still be a mistake, but at least like you're doing it intentionally for some specific reason, and you would want to add a code comment or something saying why you're doing it or whatever, if for some reason you need a contractual setup between the classes like this.
Yeah. Or maybe even where where it comes.
Yeah, I guess it's hard to know because it's like the classes are named A and B and the instance variable is C, so it's like hard to, there's not a, that's an interesting point, is that there's no actual underlying use case or modeling happening here. It really is just syntactical or whatever, or mechanical.
Yeah. I think you can continue, Newton. Sorry for the very long tangent.
No, I was actually following the discussion, though I don't know. I don't know if you guys have talked about like the solutions to the code smells. Nelson mentioned feature envy and appropriate intimacy. I don't know if you guys have talked about the solutions, the potential solutions to maybe those code smells.
So sometimes I don't see an obvious solution, and I'll just document the code smell in a code comment, you know. Or other times I might move the data from one class to another. Or like Nelson just said, maybe we only need one class with defaults instead of two different classes. So Nelson gave an example. You might be able in some situations to combine. It's like having the two classes might actually be over engineered or something. You know, a code smell I run into often that I don't know how to fix often? I feel like it's a code smell anytime I pass self to a method. But I do it sometimes, and I'll often put a comment like, why do I need to pass self to this other class? Well, you know, figure out a way to fix this. And sometimes I can figure out a way to fix it by changing the design of the classes and methods. Sometimes I just can't figure out a way to fix it, and I really will just leave a comment saying, you know, this is to do, this is a code smell, figure out another way to do, or like consider other ways to do this, but I can't. So sometimes you see the code smell and you actually don't know. Like identifying the code smell and knowing how to fix it are almost like sometimes independent issues, if that makes sense.
Okay, so moving on into
Either one I think can happen. So it's like it almost it just feels to me like I must have the arrangement of the classes and methods designed in a suboptimal way, but it would be something like I've got some class that's managing, let's say like I have like a command line interface class that's managing a bunch of command line options. And so I have like a command line option class. And then at some point, some reason arises where I need some kind of, it might be either data or behavior on the top level class, but there's not like an easy, clean, intuitive way to like restructure it or whatever. But it just feels wrong. It feels like at some point this option class, and I'm making up this example, I don't know if I've written, I would have to go search my code to find like a real example and see if we could find a solution, but it's like this option class used to be self-contained, and now it needs to know about its parent like container or whatever. So I guess that's the thing. It's like sometimes I have a design where you kind of have like some objects being contained by other objects, and the contained objects don't know about their containers. It kind of reminds me of this other thing where a super class didn't know about its subclass, and now all of a sudden it does. It's like you're like designing it, and all of a sudden like you had a thing where things were able to function independently of their parents, and now it can't get its job done without knowing about its parent. So then the parent winds up passing self to it. Does that make sense, Nelson?
I feel like I've done
And,
something like that before. And it makes me feel like you have maybe a weird sort of dependency shape, maybe like a cyclic kind of depend. I don't know if
exactly. Well,
I'm
you
understanding
do. Yeah, you
something like
totally
that,
do.
right?
That's not, yeah, I feel like that's a smell. I feel like if you're passing self to the method of another class, you have a cyclic dependent. You have a bidirectional dependency, and that might actually be what the smell is. That might be what's setting off my intuition. The problem is that it's sometimes when I look at this, I can think of a way to change it so that that doesn't happen, but sometimes I actually can't. Or I can think of a way to change it, but it actually is even less intuitive, um,
Mm.
or more problematic in other ways. And if that winds up happening, I actually just put a note in the code that like this feels wrong, but I'm unable to think of a less bad alternative at the moment, you know?
Yeah, I feel you. So it's any way you can.
Hmm. Yeah, absolutely. Dude, I agree. It depends on the problem, but I definitely agree with that. I think so. I almost feel like the smell is like an indication that I either don't properly understand the problem or I don't properly understand the solution to the problem. There's something off about my mental model. And it's almost kind of frustrating. And I guess I could try. I sometimes don't have time to throw away the
Yeah.
code and try again. So it's like I really would like an iterative approach to a better design, and maybe there actually isn't an iterative design approach. Maybe I really do need a discontinuous approach, which is, if you there's nothing more discontinuous than throwing away the code and starting over. So it could be that there's just no incremental path forward to a better design, and maybe that's the problem. And if that's the case, then I'm making the right choice by just commenting the smell and moving on. If the alternative is starting over and I can't, and that's not a real option, then it's like, I'm kind of trapped at that point.
Yeah. At least it
But
works,
yes,
and it's only just a smell at this point, and so it works for now. You just leave it that way. Makes sense.
Okay. So this is the last section in the chapter, and we'll be looking at global variables. So Ruby has some global variables by default, for example, load path and then verbose, and then these global variables that are related to standard input and output. And most of the time, um, using global variables is not entirely discouraged, As for example, you might have use cases whereby you want to use the global variables that come with Ruby itself. But then most of in the few cases where you feel like you want to create a global variable or your own global variable, in those cases, you're better off using another approach as opposed to you creating your own global variables. And this the code in this section mostly it tells you about the main issues with using global variables in Ruby are the same as global variables in any programming language, which is that the coding style is poor, and then they result into code which is hard to follow. And then you also have conflicts whereby if you have a global variable defined somewhere and then somewhere in your code base, and then that same global variable is defined somewhere else in the code base, you end up with a conflict between these two global variables that share the same name. And to illustrate that, he gives a class here. You have a class that has the class sum object, and it has a global variable named current user. And then somewhere else in that same application, you have a current user or another global variable called current user pointing to something else entirely. So that is the conflicting issue he mentioned about. And then he proceeds to give you various approaches to replace global variables. For example, using class instance variables as well as constants themselves. So in this case, you have an invoices processed constant equaling to object.new, and then you have you end up using the invoices processed constant to do the calculation, which ends up in you printing a dot every time you've processed 100 invoices. And then he also presents another approach whereby you use class instance variables entirely as opposed to using constants as well. Yeah, and I think that is the end of the chapter.
Yeah, I wanted to mention Newton. I so I remember when I was first learning Ruby and learning not to use global variables. I don't think I had much to compare it to, except for one project that I had done before in JavaScript. It was a very simple project, and I feel Newton should be familiar with this. The calculator project in
Yeah.
building projects foundations, right? You
Mm.
know, if you remember that project, everything is in one file because
Yeah,
it's
yeah,
very basic JavaScript. We hadn't learned about modules and importing stuff, so nothing was compartmentalized. It was just in there. So if you wanted to add more features, it could get confusing real fast because
yeah,
everything's referring to the same input and the same stuff. I think that's like a good enough example where there's no structure. Everything on that in that file can access everything.
yeah.
We don't want that in our Ruby code. Sorry if
So, mm,
nobody else relates to that example. I just wanted to.
yeah, I remember that because it was before they introduced the whole modularizing the code. So everything you have to you write in that one file.
Yeah,
Yeah, and it ends up being like very messy.
yeah, real fast.
Yeah.
Yeah.
Mm. So maybe I have a question about this code, and I don't get the purpose of the instance eval here, because it calls instance eval on this invoices processed constant, which is an instance of
Mhm.
object, and then he passes a block, and then inside that block is where he defines the processed method, and that's where he accesses and iterates. He continues adding incrementally to that class instance variable called processed.
Yeah, he's
Then you
using a closure here. I actually wouldn't do this either. Oh wait, no, he's not using a closure. So this looks like it's actually operating with the singleton class again, to be honest. So I wonder if you do instance eval on something like this. Well, no, it's not the singleton object. I'm actually kind of confused because I would not have expected that DEF line to function. I would have expected an error when writing DEF processed. But I guess this works. So I suppose I don't know certain details about instance eval. One thing I will say is that in my opinion, this is still a global variable. So I actually don't see the point of this personally. Like if you're willing to do this, then you can also just use a global variable. You could avoid the global variable anyway, but I guess if it's a top level constant, you know, I guess I don't see the difference between a top level constant and a global variable. Other than like you're going to get a warning if you reassign to it, that kind of thing. So I would rather encapsulate this in a class, which is also, if it's a top level class, it's also a quote unquote global thing. You know, if you're not scoping it to a module, and if you scope it to a module, then that module is a global thing. But regardless, I wouldn't solve this problem this way unless I was writing a really tiny program. And if I'm writing a really tiny program, then I feel like things like global variables no longer matter that much unless you have a ton of dependencies or something. Like if you have a one-off script with no dependencies, it doesn't really matter if you use a global variable that much. I still wouldn't do it just out of habit, but yeah, I guess like when I look at this, I see a global variable. That's how I interpret what I'm looking at. It's not it's not lexically, it's not grammatically a global variable. Grammatically, it's a constant, but uh, when you think about the problems of global variables, it's collisions. Like you're polluting a global namespace. You're maximizing the footprint of the namespace where collisions could occur. And I feel like you're doing that whether you're using $ invoices or capital invoices personally.
So maybe another thing, and I don't know if this is just that I understood this code wrong. So the problem here is that he wants to print a dot every time you've processed 100 invoices, right?
Mm-hmm.
So he adds one every time he processes an invoice. And then I imagine, okay, I'm giving an example. Let's say you have processed being equal to 100, right? And then he says processed divided by 100 is equal to 0. If that condition is true, then you print a dot. In my opinion, it should be if processed is divided by 100, if the value you get on performing that division is greater than 0, you should print a dot. Because now if you have 100 invoices and you divide by 100, you expect to print a dot. But then this condition, 100 divided by 100, it equals to 1. It doesn't equal to 0.
I think it's
Well,
not divided.
this is the modulo. Yeah, this is the modulo.
So it's making it
Yeah.
cyclic in its sense. So when it gets to 100, it starts at 1 again. After 0, it starts at 1 again and keeps going. So even when you're at 200 or 201, you get when you get to 200, you get 0 again, and 300 and 400 and so on,
Yeah.
like that.
It's the
Cycles of
remainder.
100. It's the remainder operator. Yeah.
Yeah, it's the you do the division and then that expression results in the remainder.
Oh, I thought it was regular division. Okay, my bad
No.
when it comes to that. I thought he was going for the number, not the
Yeah.
remainder.
Cool.
Yeah. So I think that's pretty much it, unless you guys have anything to add.
So I think nothing. Oh, can you say that again, Nelson? Okay.
Yeah.
Well, I guess this is trying to print out a progress indicator. So I think it's like kind of a separate problem. Like, because this isn't going to clear, if it cleared the screen, it would still, I think that would be a little different, Nelson. I think you'd get, it could be good output, but it would be different output, I think. Yeah, I think it is. Yeah, I think that's
Yeah.
the idea, is like to show
Yeah, true.
progress.
Yeah. So yeah, that is it for this week. Next week
I
we'll
will
be
say,
covering.
like, I can say one real quick thing. I would encapsulate this in some kind of, and I think I already said that. I would have like an invoice processor,
Yeah.
or like I love to do commands, and so I might have a command called process invoice. But a common way would be invoice processor, and then it could maintain its own internal runtime state, So I just wouldn't design the code like this in an object-oriented programming language anyway, personally. So, but I think the author is also trying to give examples of certain things. So I don't think he's trying to demonstrate object-oriented design. But
Yeah, I think so too.
I mean, if I saw
feel
this,
like- yeah.
yeah, if I saw
Sorry,
this in a
Miles.
pull request, I was just gonna say, if I saw this in a pull request, I think I would push back on it. I think this, it depends. I mean, I would need more context, of course. Like I said, if it's a
Yes.
tiny program, I wouldn't care. But if this is a large program, and remember how we were talking about mental models, Nelson? Or you were mentioning, like, if you throw it away and rebuild it and improve your mental model over time, it's just like, if you're on a program, if you're writing a larger program where the mental models matter, I just feel like if you're using an object-oriented programming language, but you're doing this to handle it, I just see problems here that I would push back on personally. I would recommend
Yes.
alternative approaches.
I don't know if it's because the author I don't know if it's accurate to say that he mainly writes libraries, or maybe because he writes libraries, and I feel like that may be like really arcane, like you said, type code. Like
Yeah, that's a good point. I hadn't thought about that. So
And
if you're spending a lot of time writing libraries, you're
Yeah.
going to use methods like instance eval. If you're never writing libraries, you're probably never going to use instance eval ever.
Yeah.
So that's
And he does a lot
that's
of-
actually a good point.
Yeah. So I think this is it for today. Does anyone want to volunteer for next week? Chapter 4. Let's see.
Oh, sorry, I
Chapter-
froze for a bit. I didn't hear
Oh.
Miles's conclusion on this stuff.
Oh, I think I just agreed with you. Yeah, I think, right? I can't remember what I said, but I think I was just agreeing with you.
Okay,
Yeah.
cool.
Oh, no, I remember what I said. I said I did agree with you, but I did mention if you're writing libraries, you're more likely to use something like instance eval. And if
Yeah.
you never write libraries or anything like libraries, then you could do a long Ruby career and never use instance eval a single time.
True. Yeah, that makes sense to me. Yeah.
So I was basically just saying that I agree, and it's a good point.
Mm.
Okay. Awesome.
So the next chapter is about methods and their arguments. That's chapter 4. And let me try to see how many pages it has. Oh, actually. Oh, okay. Seems like a long one too, but anyway, we'll see how that goes.
Yeah, I think you can go to the table of content, and you can see how many pages. That's from yeah, like at the beginning of the book. If you scroll up to the table of content, yeah, chapter 4.
I do know the author
No,
said both chapter 3 and 4 were very long, so it
Oh
it
yeah,
might be that
very long.
we might want to split them.
yeah, it's
Yeah,
about 50 pages or so.
it's like over 30 pages.
Yeah,
Mm,
40 actually,
no, yeah. So
or
yeah,
40 plus.
mm, I think Nelson will take us through the next session. Take care, guys.
Okay.
All right, have a good
Mm,
one. Cheers.
okay,
Peace, everybody. Take care.
thanks.